Here's a question involving two triangles, A and B, and we put them together to make a larger triangle. Question is that larger triangle right-angled or not? So let's look at the logic of this situation. Here's the larger triangle, and so that we can talk about it, let's call it P, Q and R. So this side will be little p, this will be little r, this will be little q. Now there's several things going on. That if it's right angled, if triangle PQR is right angled, then it must mean that p squared is equal to q squared plus r squared. Now that's logically equivalent to saying if p squared does not equal q squared plus r squared, then it must mean that triangle PQR is not right angled. It's sometimes called the contrapositive of that original statement. It's not the inverse of Pythagoras' theorem. We're just restating this. If it's raining, then the grass is wet. If the grass is not wet, then it's not raining. So we're just saying exactly the same statement, but using the reverse with negatives. So we really have to find out whether p squared is the same as q squared plus r squared. And in this larger triangle, we know that this is 19. We know that p, 16, plus 6 is 22. And we know that q, that's 8, is 8. So let's have a look at this. P squared, well, let's work out q squared plus r squared first. Q squared plus r squared is 8 squared plus 19 squared. A little bit of work on the calculator here. 8 squared plus 19 squared. That's 425. And let's look at p squared. 22 squared. Well, that's 484. So what can we conclude? We can conclude from this that p squared does not equal q squared plus r squared. So we conclude that triangle PQR is not right angled. And that's what we were after. Is the larger triangle right angled? No, it's not.